This is Unit 7, Day 4. Alright, so today we're doing polynomial long division. It says we've worked in the last unit to simplify rational expressions. Don't forget that your algebraic fractions. In this lesson, we will look more closely at the division of two polynomials and how it is analogous to the division of two integers. Alright, so think about old school. When it said 1,519 divided by 7, we also could rewrite it as a fraction or it could look like this. Okay? A couple things to remember. This number on the outside over there is called the divisor. Okay? The answer that we actually get, okay, the answer that we get is called the quotient. Remember, it's the answer that you get when you divide. And then the number underneath is called the dividend. Okay, so those are all three parts there. All right, so let's think about how we used to do this. So you used to say 7 can't go into 1, so then we would say, well, how many times can 7 go into 15? 7 can go into 15 two times. 2 times 7 is 14. We'd subtract it and we get a 1. Now, 7 could not go into 1, so we would drop down the other number and it becomes 11. So then we say, well, how many times can 7 go in 11? 7 can go into 11 one time, and 1 times 7 is 7 with a remainder of 4. 7 couldn't go into 4, so then we would drop down the 9, and then you say how many times does 7 go into 49, and it goes 7 times. 7 times 7 is 49, and then you would have 0. And don't forget, 0 is always called your remainder. Okay? So then we knew that our answer, that 7 goes into 1,519 times, or 217 times. It says rewrite your result as an equivalent multiplication. That means 7 times 217 would result in 1,519. Part C. It says now evaluate using long division. So now the number has changed a little bit again. So 7 goes into 15 two times. 7 times 2 is 14. 1 left over, carry down the 2. 7 goes into 12 one time. You multiply 1 times 7, you get 7, remainder 5, carry down the 2, 52. How many times can 7 go into 52? 7 times. 7 times 7 is 49. And now I have a remainder of 3. Okay, so back up to the top here real quick. Now our divisor is our C. Okay, we're going to talk about that in a minute. What we get is our answer. Our quotient is our A. And our remainder is always our B. So let's look at these parts here. We have our A, which is the answer. We have our B, which is the remainder. And we have our C, which is the divisor. Okay? So and that says write your answer in A plus RB form. Alright, so remember, our A is our quotient. That's 217. Our B is our remainder. Our remainder in this case is 3. And our C is our divisor, which is 7. So again, look, here's my A, there's my B, there's my C. So now when it wants it in this form, it'll be 217 plus a remainder of 3. And now it says write it in A plus B over C form. So my A is 217 plus my remainder, which is 3, out of the divisor 7. Okay, so that's like saying 217 and 3 sevenths. All right, part D. Write your answer from part C as an equivalent multiplication equation. All right, well, it's the same as saying I could take 7 and multiply it by 217. But we found out from part A that that's going to be 1,519. But then you'd have to add 3 in. There's your remainder. Okay, that's your remainder right there. And that would result in our 1,522. Okay? Or another way you can write it, it's 7 times 217 and 3 sevenths. And that would result in 1,522. All right, example 20. Now, the reason we tried just like an old school long division was just to let you guys know that the process is going to be the same. Make sure you're listening. It's going to be a little bit harder. All right, so long division. So you're looking at x. You're going to look at this x, and you're going to look at that 2x squared. And you're going to say, well, how many times can x go into 2x squared? Well, I always say, well, how do I change an x to a 2x squared? What do I have to multiply the x by to get to 2x squared? Well, I'm going to multiply it by a 2x. And if you notice, I didn't put it up here. I put it over here, and it's sitting above the x term. Again, because 2x times this x would be 2x squared, and that's what we're looking for. Okay? So now, let me get rid of all these colors. When I multiply 2x times x, okay, I'm going to get a 2x squared. But then I also have to multiply the 2x times this positive 6, okay, and I get 12x, but then the whole thing goes in parentheses and is subtracted. And when you subtract something, you're changing the signs. So this becomes a negative 2x squared, and that becomes a negative 12x. Now, I add them up and down vertically. Okay, so when we subtract them vertically, you always want this to cancel out and be 0. And then you have 15x take away 12x, and that results in a 3x. So I'm left over with 3x. Okay? All right. Now, you're going to say, how can I make this x change to a 3x? Okay? So x times what gets me to 3x? So, if I take those colors away, I know it's positive 3. Because when I multiply a positive 3 times this x, it'll result in a positive 3x. So I write 3x. But then I also have to multiply this positive 3 times that positive 6. And when I multiply positive 3 times positive 6, oops, sorry, I was supposed to bring down the positive 18. I get positive 18. Okay? That was brought down originally. Now, this wouldn't make sense to not change the signs. So you put it in parentheses, and it has to be subtracted. So now that goes to plus, that's a negative 3x, and that's a negative 18. So now I have 3x minus 3x, 0, 18 minus 18, another 0. Okay? So now part B says rewrite the results you found in part A as an equivalent multiplication equation. So that's telling us that if I take x plus 6 and I multiply it by 2x plus 3, it should result in a 2x squared plus 15x plus 18. So, again, my quotient, 2x plus 3, times my divisor, which is x plus 6, would be equal to my dividend, which is underneath that division symbol, which would be 2x squared plus 15x plus 18. All right, part C. Write this in Q of x where R, so this is like that whole ABC again, okay? Now, Q of x is the quotient. Okay, remember we called that A in the first example. R is the remainder. We called that B. And there we go. And then there's my divisor, which we called C. Okay? So, it's going to be your answer. So, 2x plus 3 plus our remainder. In this case, our remainder was, oops. We actually have to do this one. It's not related to the other one. Okay, so x plus 6 is going to get divided into 2x squared plus 15x plus 20. So now remember, you're saying how can an x change to a 2x squared? Well, if I multiply it by 2x. So 2x times, so this 2x times this x would be 2x squared. Now this 2x times that positive 6 would be positive 12x. Okay? So the only thing different is the 20 here. So now remember, you put it in parentheses, you subtract, but then that subtraction sign changes all the signs here. Okay, so you want this to cancel out and be a 0. So you're going to have 2x squared minus 2x squared. I'm sorry, 2x squared minus 2x squared, that's 0. 15 take away 12x, and you're going to get 3x. Okay, then you drop down this 20. So I'm going to carry down the plus 20. Now you're going to say, how can I change this x into a 3x? So you're going to say x times what would give me a 3x? And it's times 3. So this becomes plus 3. So 3 times x would be 3x, and 3 times 6 would be 18. Put it in parentheses, subtract, and then it changes all the signs. So that becomes negative 3x and negative 18. So now 3x minus 3x is 0. These should always cancel. And now you have 20 take away 18, and that's going to have a remainder of 2. So remember, this is like my a, or my qx, okay? That's my quotient. My b is the remainder, or my r, and then my c is my divisor. So when I put it in the form that it asked me to up here, then it's the answer plus, why is it plus? Because the remainder is positive, 2 out of what I divided it by, which was x plus 6. There's my answer right there. Okay? Alright, it says write it as an equivalent multiplication equation as well. So it could be when you multiply x plus 6 times 2x plus 3 with a remainder out of x plus 6, you'd get the same thing. Or it could be x plus 6 times 2x plus 3 plus the remainder, which is 2, would equal, and I ran out of space there, your 2x squared plus 15x plus 20. Alright, example 21. We're going to keep working on and on and on and on forever. But something to pay attention to in the text box. It says, how we're writing it is known as the quotient remainder form. So this little form right here, where you have the quotient plus the remainder out of the total divisor. Okay, example 21. Alright, so it wants it in quotient remainder form. So ready? I'm going to take x minus 3, that's my divisor, and it's going to be divided into my x squared plus 2x minus 5. Remember, that's the dividend. Alright, so now you're going to say, how can an x change to an x squared? What do I multiply x by to change it to x squared? Just an x. Okay, so now, when I take, trying to get this yellow away, sorry. When I take x and I multiply it by x, I'm going to get x squared. When I take this x and I multiply it by negative 3, I get minus 3x. Put it in parentheses, subtract, but now all the signs change. So this goes plus negative x squared, positive 3x. So again, these should always cancel, but I have 2x plus 3x, and I'm going to get 5x. Okay? I drop down, carry down the minus 5. And now I say x times what gives me a 5x? Well, a plus 5. So 5 times x is 5x. 5 times negative 3 is negative 15. Put it in parentheses, subtract, change all your signs. So this is going to be negative 5x, positive 15. As always, 5x minus 5x will cancel, and I have negative 5 plus 15, which is going to be 10. All right, so ready? My answer. This is my q of x right there. This is my remainder, and then that's what it's being divided by. So I have x plus 5 plus remainder of 10 that was originally divided by x minus 3.